Let's go ahead and get started. So this video is about combined gas law, okay? First thing you have to know about combined gas laws, there's a couple things that we need to make sure that we have going on. Number one, we need to make sure that all the units on the left, in other words, the ones and all the twos have the exact same unit. So if they're not, we have to convert from one to the other. Second, we need all of our temperatures to be in Kelvin. So if it's in Celsius, add 273. If it's in Fahrenheit, do the conversion from the slides. Okay, and then finally, the last thing we need to see is there anything that doesn't change from the left to the right? And if it doesn't change, we can cross it out of the equation and pretend like it's not even there at all. So this is number 6 on your worksheet. It's the green question. It's the one that people have said, why is it green? Well, there's no real good answer of why it's green, but here we go. Okay, so we have P1, V1, T1, we got P2, V2, and T2. Okay? The question says 78.5 milliliters of oxygen is collected at 42 degrees Celsius with a pressure of 767 milliliters of mercury. Find the new volume at STP. So the first place that I would start is, what is this question even asking us to solve for? Well, if we read the question, it says find the new volume. So the new volume is this guy right here, V2. Okay? And it also says find the new volume at STP. STP is really important. Hopefully you've looked at your notes. Hopefully you had the Zoom call and you've heard what that means. But STP stands for standard temperature and pressure. So we'll get to that here in just a minute. So we also have all 3 of the original parameters given to us. It says that we have 78.5 milliliters. Well, that's a volume. Okay, so 78.5 milliliters is a volume. Okay, we also have that there's 42 degrees Celsius, but we don't want 42 degrees Celsius. We want to take 42 and we want to add 273 to it. So we know the initial temperature is 315 Kelvin. And we also know that the initial pressure is 767 milliliters of mercury. Now, again, just a reminder to you, all that we care about is that these units do not change from the left to the right, that they're the same on this side as they are on that side. Okay, so we have milliliters of mercury here, we need milliliters of mercury here. We have milliliters here, we need milliliters here, we have Kelvin here, we need Kelvin there. Here we have this STP. Now, if you review your notes, that says that standard temperature and standard pressure is a temp is 0 degrees Celsius and standard pressure is 1 atmosphere. Okay, now neither one of those numbers are particularly helpful to us because we have milliliters of mercury here and we have Kelvin here. So we need to do a little bit of conversion, okay? Now, if you remember from our conversions, 1 ATM is the same as 760 milliliters of mercury, okay? Or if you're looking about like dimensional analysis, how does that work? 1 ATM, 760 mmHg. Okay, it looks like that. So we can go ahead and put 760 milliliters of mercury. That is the same as 1 ATM. Also, we don't really care about 0 degrees Celsius because 0 degrees Celsius is not going to help us. But if we add 273 to that, then 273 K is helpful. Okay, so there we go. Now we have our P2, we have our T2. We're going to solve for V2. None of our numbers are the same on both sides. This was close, but they're not the same on both sides. Okay, so now we need to go ahead and plug it in and do the work. So
okay, now you rearrange this equation to solve for V2. So we're going to divide both sides by 760 milliliters of mercury and 315 Kelvin. So temperature goes away, pressure goes away, we're left with V2, and we can simplify this.
up with V2 is equal to. Now, I would highly recommend that you simplify the numerator and then simplify the denominator. Okay, looking at units, K goes away, milliliters of mercury goes away, we're left with milliliters. So 68.7 milliliters. Hope that helps.